friends, in this video we will study the interfacing of the hex keyboard to the 8051 microcontroller. First of all, we will study that what is the keyboard, what is the configuration of the keyboard, what is the circuit for it, and then we will see that how it is interfaced with the 8051 microcontroller, its circuitry and its explanation. So let us start with our topic. So first of all, what is a keyboard? We know that keyboard, it is an input device, and this input device is used to give the input data to the microcomputers or the microcontrollers. Okay, so it acts as a human interfacing device. Interfacing means that the communication path. Okay, so because if the humans, they want to interface or communicate with the microcontrollers or microcomputers, then how they are going to provide the data to the microcontrollers? For that we use the keyboard. Okay, so we can say that keyboard is a human oriented input peripheral. Human oriented because the humans are going to use it, and input because the data is being given to the microcontroller or microcomputer, and peripherals because it is an external device. Okay, so how this keyboard is used? This keyboard is used to input data. So this keyboard is used to input the data or the program into the microcomputer or microcontrollers. Now this keyboard, it consists of the push button type switches. Okay, so in keyboard we know that we are having various keys. Okay, so when this key is pressed, inside that key there are push buttons which are present, and these push buttons, they act as a switch. So we can say that the keyboard, it consists of so whenever the humans, the user, it is going to input the data, it is going to press the key. Okay, and that key is going to give a specific code to the microcontroller. The microcontroller will identify that which key is being pressed, and according to that key it is going to process the data. Okay, so when a key is pressed, the microcontroller identifies key depression and performs the appropriate operation. So as I have said that the keyboard, it consists of the push button type switches, and these push button type switches are present inside the key. So whenever the key is pressed, the push button is also pressed. Okay, and that key is going to generate a code. Okay, and that code is given to the microcontroller or microcomputer. The microcontroller will decode that code and then perform the appropriate operation associated with that key. So if we see the general operation of a keyboard, here we will have a encoder, So you can see that in the keyboard, as I've said, there are push button type switches. So these are the keys. Okay. When this key is pressed, this push button is going to be closed. Okay. So it means that a key is pressed. So according to that key, an 8-bit character code will be generated. Okay. The key depression will be encoded into an 8-bit character code. This code will be given to the microcontroller, and the microcontroller will decode that code, and then it will identify that which key is pressed and what operation it has to perform. So each time a key is pressed, a code is generated and transmitted. There is only one code associated with the key. So it means that when this key is pressed, an 8-bit code will be generated. When this key is pressed, then another 8-bit code will be generated. So every key will have a one particular proper code associated with it, so that when the microcontroller decode that code, it is going to identify that this key is being pressed. So for each key, there is a one proper or one particular code for it. So in the keyboard, as I said, that the keys, they are in the form of the push button switches. Okay. So each switch, it is going to make an electrical contact when pressed. Okay. So this is the push button. When it is pressed, it is in the form of the key. So when it is pressed, it is making an electrical contact. Okay. So this circuit will be completed. Now when this circuit is being completed, the output will be generated. Now this electrical contact, it should be reliable, it should be good, and it should have a long life. So this electrical contact, or we can say the metallic contact, this is going to bounce few times. Okay. So this metal contact, when this switch is pressed, then this metal contact is going to bounce few times. Because now when this contact is being connected, there is an output. Okay, we will get an output voltage here. But if this metal contact is going to bounce again and again, then this output voltage is going to fluctuate. And due to this fluctuation, there is a spike in the output signal. And these spikes can be represented as, so the output signal will be in the form of this. There will be spikes in the signal, and these fluctuations are due to this metal contact which is bouncing back. Okay, so suppose that this is the metal contact, this is going to touch. When this key is pressed, this is going to just fluctuate or repeat itself, or move at its position for some time. So contact is made, then it is removed, then made, then removed, and then it is made for a constant time. So when it is removed again and again, the metal contact is bouncing. At that time, these spikes are being produced. When the key is continuously pressed, then we are getting a constant voltage. After that, when this key, after coming back, when this key is released, okay, when we are removing our finger, the key is again coming back to its position, then this is the key depressed. At that time also the metal contact is going to bounces back. Okay, so it is the problem associated with the mechanical switches in which we are having a metal contact. Okay, this bouncing problem is related with the mechanical switches. Okay, and now as in the keyboard we are having these mechanical switches, the push button type, the mechanical switches are present. So in keyboard also we are having this bouncing problem. So for that, the mechanism used to remove this is called the key debouncing. Okay, now this key debouncing is done by two ways. One is the hardware and other is the software. That how the problem of this metal contact bouncing again and again, that can be removed. It can be removed by hardware also and by software also, and this process of removing this is called the key debouncing. Okay, so let us first see the key debouncing by the hardware. How the problem of this fluctuating output voltage can be removed. Okay, so in this hardware key debouncing, it is implemented with the help of a flip-flop or latch. Okay, so when the key is pressed, with that key the associated circuit is going to consist of a flip-flop or a latch. RS flip-flop is connected. Let's see the circuit for this. So this hardware key debouncing, it can be implemented with the help of this flip-flop or a latch can be used. Okay, now when this P, the key is pressed, okay, it is going to make contact with the A. Okay, one time it is making the contact with A. At that time the output of the latch is will be high. And when this metal contacts with the B, then output of latch goes low. So when it is at A, output is high. When it is at B, the output is low. Okay. Now when this switch is between A and B, the output is not going to fluctuate. Because it is the property of the latch that it is going to store the value up till the next variation. So here also when the switch is at A, then the output is high. When it is at B, the output is at low. So you can see that no debouncing is present. Debouncing means that in this way spikes are present. Okay, so in the output signal no spikes are present. Either we will have the high value or the low value. So the hardware debouncing is implemented with the help of flip-flop or a latch. RS flip-flop or a latch can be used. Okay, So between at A, the output is high, at B, the output is low, and between A and B, the output of the latch remains constant. Okay. Now, second type of debouncing is the software key debouncing. Now, software key debouncing, it is implemented with the help of the program. Okay. So in that, the microcontroller, it is going, whenever any key is pressed, so after the pressing of the key, the microcontroller is going to wait for 20 milliseconds. After 20 milliseconds, it is going to check that whether the key is pressed or not. If after 20 seconds again the key is found to be pressed, then it is going to generate the code for that key and process the operation. Okay. So there is a 20 milliseconds of time which the microcontroller check that is the key still pressed or not. If the key is still found to be pressed, then that key will be processed. So that is done with the help of the program. So it comes under the software key debouncing. So here, let's see the flow chart. First of all, the program is going to start, then it is going to read the keyboard. Then it is going to find that is key is pressed or not. Then there can be two conditions. Either the key is pressed or the key is not pressed. If it is not pressed, then it is going to again read the keyboard. Okay. After that, if the key is pressed, then there will be a delay of 20 milliseconds. Then it is going to again read the keyboard. When it read the keyboard, it is going to check after that is key is still pressed. If yes, then accept the key and return. If the key is not pressed, then again come to this step. Again read the keyboard and check that is the key pressed or not. Okay. So every time it is the microcontroller is encountering that a key is being pressed, every time it is going to read the keyboard. If the key is pressed, it is going to provide a delay of 20 millisecond. After 20 millisecond, it is going to check that whether the keyboard is again it is going to read the keyboard, check that if the key is still pressed or not, and if it is still pressed, then it is going to accept the key, otherwise it is going to reject the process. Okay. So in this way, the problem of the metal contact bouncing again and again, that can be reduced by using the hardware part also and using the software debouncing also. Okay. So this was the keyboard. Okay, we have seen the internal circuit of the keyboard, that what the keyboard consists of, how the keys are pressed, and how these keys are being identified by the microcontrollers. Now let's see the interfacing keyboard circuit of the keyboard, that how the keyboard is connected with the microcontroller, what will be its communication circuit, interfacing circuit called. Now the keyboard, when it is interfaced with the microcontroller, it is connected with the input ports of the microcontroller. Okay. So here if we are having keyboard, in keyboard we have the keys. Okay. So these keys are connected with the microcontroller. In microcontroller, we are having the input ports. Okay. Now we know that the keys are the mechanical switches. Okay. So in the keyboard, the keys will be connected with the input ports, and keys are the mechanical switches. Now these mechanical switches, they are arranged in two ways in the keyboard. One way is the matrix form. In the matrix form, the switches can be present, or another form is called the non-matrix form. So there are two ways in which the mechanical switches, they can be present in the keyboard. Let us see these two forms, the matrix form and the non-matrix form. First of all, we will see that how a non-matrix keyboard, it is interfaced with the microcontroller. In the non-matrix type keyboard, the keys, they are present in the simple form. Means that each input port line, it is connected with each key. Okay. Suppose that there are 8 keys in the keyboard. So those 8 keys would be connected with the 8 lines of the input ports. So every input line is connected with each key. Okay. So here, if we see the diagram for it, this is our microcontroller 8051. In this 8051, we are having different ports. We are using port A, okay, and here each port, because each port is going to have 8 lines over there, so PA7, PA6, will start from 0, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so here with every key, okay, so you can see that the each port line, it is connected with the keys. There are 8 keys from 0 to 7. Okay, and whenever any key is pressed, you can see that those port line will get activated. Okay, so in this way, whenever the 8051, it is going to read its port. Okay, and at that port, whatever the data it is getting, according to that, it will identify that which key is being pressed. Okay, so number of keys is equal to number of port lines. If there are 8 keys, then 8 port lines are required. Now in this non-matrix type of keyboard, if you want to identify a key pressed, then how it is done? So here, to identify a key pressed, first of all, identify that whether a key is closed or not. Identify the key closure. After that, debouncing the key. Then, after that, encoding the key to an appropriate code. Now here, debouncing the key, it can be done either with the hardware debouncing can be used or software debouncing can be used. Okay. Now here we have seen the hardware debouncing, that how the hardware, with the help of hardware, how the key closure is being identified. Okay, now here you can see that whenever this key is closed, the circuit will be completed and the VCC voltage will be provided at that. This line will be at logic 1. Okay, now if we connect all these lines with a NAND gate here, and how we are going to identify that whether the key is closed or not. Okay, so to identify the key closure, all the lines will be connected with a NAND gate, and the output of that NAND gate, if it is high, it means that key is closed. If it is low, it means that no key is being pressed. Okay, so if we connect all these with the NAND gate, let's see, these are extended, and all these lines will be connected as an input to a NAND gate. Okay, so here I have drawn this NAND gate. The input will be all the 8 lines coming from the keys. Okay, and the output of this NAND gate will be a strobe signal. Now when all keys are open, then the output of NAND gate is low. That means that STB bar, this signal will be activated. Okay, this way, the output of NAND signal is going to low, STB is going to be low. Okay, now when any key is pressed, output goes high. Okay, that means STB bar signal, it goes high. So when all the keys are open, the output of the NAND gate is going to go low, and this is STB strobe signal, it is also going to be low. And when the key is pressed, the output of the NAND gate goes high, the STB strobe signal goes high. Now to identify whenever this strobe signal is high, it means that the key is pressed, and we can use this strobe signal to interrupt the microcontroller. So we can say that whenever this strobe signal it goes high, it means that key is pressed, and then interrupt the microcontroller. Microcontroller is going to read that which key is being pressed, and then it is going to encode the key to an appropriate code, and appropriate operation will be taken. So in this way, a non-matrix type of keyboard, okay, that can be interfaced with the 8051 microcontroller. We have seen that in the non-matrix type of keyboard, the number of keys is equal to the number of port lines. Okay, so how many keys we want to interface, according to that the number of port lines will be there. Okay, if there are 8 keys, then 8 port lines. If there are 16 keys, then 16 port lines will be required. Okay, now the next type of keyboard is the matrix type of keyboard. Now, as in the non-matrix type, the number of lines is equal to number of keys. Now, as the number of keys is increasing, the number of lines required is also increasing. Like 16 keys will require 16 lines. If there are 32 keys, then 32 lines will be required. So the circuitry is increasing. Now to reduce those circuitry or the requirement for the input lines, if we want to reduce that, we can use the matrix type keyboard. In this matrix type keyboard, the keys are present in the form of rows and columns. Okay, so suppose that 8 keys are required, 8 keys are there, so it can be arranged as a 4 cross 4 matrix. If 16 keys are required, then it can be arranged as 8 cross 8 matrix. If 32 keys are required, then 16 cross 16 matrix can be used. Okay, in that there will be 4 rows and 4 columns. Let's see that how we can implement the 8 keys. There are 4 columns. Now there are 4 rows. Okay, now if we connect them, you can see 1 2 3 4 5 6 7 8. If we require only 8 keys, then this much part is enough for us. If we require 16 keys, then we can use 2 more lines. Okay, 2 more rows can be used, so we can get 16 keys: 8 9 10 11 12 13 14 15 16. Now how these keys will be implemented? These are the switches for those keys. So you can see there are total 16 keys here. So with the combination of 4 cross 4, we can implement 16 keys. Okay, so here we can have 3 2 1 0. Here also we can have row 3 2 1 0. These are the columns and these are the rows. Okay, now whenever any key is pressed, so with the help of the row and the column combination, we will be able to check or identify that this key is being pressed. Now let's see that how the 8051 microcontroller, it can be interfaced with this matrix type of keyboard. We have seen that in matrix type of keyboard, the keys are arranged in the form of rows and columns. Okay, in the form of matrix they are present. So when 8051 microcontroller is interfaced with such type of matrix keyboard, then the rows are the return lines and column they correspond to the scan lines. In 8051 we are having return lines and scan lines. So rows will act as the return lines, that is the input lines, and columns they will act as the scan lines or the output lines. Okay, so if we see the connection here, these rows, again we will have the 4 cross 4 matrix. Keys will be present here. These will be connected with the input port A return lines. These are row 3, 2, 1 and 0. These are the columns. They are connected with the output port B scan lines. Now these are connected with a resistance, and all these are connected with a power supply of plus 5 volts. Now when a key is pressed, the corresponding row and column is high, then it makes that column high, and if vice versa. So you can see here in the diagram that whenever any key is pressed, this circuit is going to complete and the row and the column, they are going to short with each other. Okay, so whenever any key is pressed, the corresponding row and column, they become shorted. So when they become shorted, because here power supply is given to this row, so corresponding column or the output line is also going to become high. Okay, and the microcontroller, it is going to read that output lines, and then according to that it is going to identify that which key is being pressed. Okay, now suppose that this key is being pressed, so this line will be shorted. Now power supply is given to this, so this line is already high, the input line. Now the if this line is shorted, then the second line, it also becomes shorted. Okay, so if this column becomes short, then the microcontroller will get to know that this key is being pressed. So let's see the process to identify if the key is pressed or if the key is pressed or not. So first step is make all the columns 0. Okay, so when all the columns are 0, the microcontroller will get to know that all keys are activated. Okay, now after that, read the status of rows. That is the return lines. Now if the status of the return line, all lines are high, it means no key is pressed. If any of the line is high, if any line is low, it means that key is pressed. So first step of interfacing is to identify that whether the key is pressed or not. Okay, so how microcontroller identify? It will make all the columns as 0. So when all the columns are 0 at output line, scan lines, it will be getting the output 0. Okay, it means that all lines are activated, all lines are shorted. Now it is going to check the return lines, the input lines. All the input lines are high because they are connected with the plus 5 volts power supply. So when all the lines are high, it means that no key is pressed. Okay, because if key is pressed, then because in columns we are giving the input low, so in the input also at the in the rows also we will get the low output. Okay, because these lines will be shorted when the key will be pressed. Now suppose that all the lines we are getting as high, it means that no key is pressed. Suppose that this key is pressed, this key is pressed, so this line will be shorted. So if it is low, then at this line also we will get a low. So by this, the microcontroller will get to know that because this row 1 we are getting as the low input line, then it means that a key is being pressed in this row. Okay, now after identifying that the key is pressed or not, next step will be debouncing the key. Now debouncing the key, it can be done with the hardware or the software, as we have discussed already. Now after this second step, the third step will be to identify that which key is pressed. Okay, so third step will be identifying the pressed key. Now how it will be identified? First of all, activate the keys from one column by making one column line 0. Okay, so what we will do, we will activate one column at a time. First of all, we will activate the third column. So third column will be activated by making all the lines as 0. We are going to activate all the keys by providing low at this, and all the remaining lines will be at logic 1. Only the column number 3 line will be at logic 0. After that, read the status of return lines. Now next, read the status of the return lines. 0 on any return line, it will indicate that that particular key is pressed. How we will do that? First of all, we have made column 3 as low. Okay, we will check that which of the return lines is 0. Okay, so suppose that row 1 line is 0, or it means it is low. Okay, after that we will make row 2 lines as low. In that we will not see that any of the lines is low. In row 1 we will check that whether any return line is low or not. We are not getting any row. Again we are getting this. Then in row number 0 we will make all the column will be make and low, and then return lines will be checked. So the case in which we are getting the return line also as low and the column line also as low, in that case the key is pressed, and we will identify that which key is pressed. In first step we were not identifying, we were just identifying that whether key is pressed or not. In this third step we are identifying that which key is being pressed. Okay, so this is how the interfacing of a matrix keyboard is done with the 8051 microcontroller. So here we have seen in this video interfacing keyboard with 8051. Keyboards can be of two types: matrix keyboard and non-matrix keyboard. In matrix keyboard we have seen that the requirement of the lines is reduced, whereas in non-matrix type the number of keys is equal to number of input lines. So when the number of keys is less, then we can use the non-matrix keyboard. But if the number of keys is more, then matrix keyboard is used. And we have seen that how they are interfaced with the 8051 microcontroller, how the key identify is the key which is pressed, that is identified. Okay. So I hope that now this topic interfacing keyboard with the 8051 microcontroller, it is now clear to you. Thank you.